Hello students. Today, in your geometry class, we're going to be discussing bisectors of triangles. Now before we start, we may want to look at these two problems really quick based off of what we did yesterday, which were midsegments, just to solve what problem 1 and number 2 are. So we're solving for y and x. So this would be a good time for you to pause your screen and do a quick double check. Hopefully you've paused your screen, or could do these fairly quickly in your head. Y turns out to be 5, and x turns out to be 40. So remembering the midsegment rule, for number 1, y is the midsegment, therefore it's half of the base. And for number 2, x is the base, therefore it's double the midsegment. Now, at the end of this lesson, you should be able to solve problems on perpendicular bisectors. So let's go over these 4 quick theorems. Now, Theorem 5.2 is the perpendicular bisector theorem, which states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So to clear that up a little bit, let's draw a quick triangle. So we have this triangle like so, and we are going to draw a perpendicular bisector. So this line is perpendicular to the base. So it's perpendicular to the base, and it bisects it, which means it cuts the line in halves. Now, what this is saying is that if we have a point, here, let's call this point A. Now, because it's on the perpendicular bisector of the triangle, that means it's equidistant from the other endpoints. Let's call them B and C. So this is B and this is C. So point A is equidistant from points B and C. The converse of the perpendicular bisector theorem, which is Theorem 5.3, states that if this point, say point A, is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. It's really just the converse, or just the reverse of Theorem 5.2. Theorem 5.4 is the angle bisector theorem. It states that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So, with that said, we can use the same, or a similar triangle to what we used earlier, and we're going to create a line segment. So we're going to create a line segment that goes through it, and it's the angle bisector, which means it bisects the angle, or it cuts the angle in 2 halves. Therefore, this angle and this angle are congruent. Now it says there, if there is a point that is on the bisector of an angle, then the point is equidistant from the sides of the angle. So if this is my bisector right here, my angle bisector, it says that if I put any point on this line, so any of these points that I'm putting out, let me make a slightly bigger circle or point. If I put this point anywhere on the line, this point, or these points rather, are equidistant to the sides of the angle, which means this side, or this line segment, is congruent to this line segment. And the converse is true as well. If I have a point A, and this point is equidistant from the 2 sides of the angle, then it's on the angle bisector. So let's practice a couple. In example 1, we have an angle bisector. And because this is true, it also means that the line segments KJ and line segment JM are also congruent. Therefore, I could say x plus m is equal to 2x minus 7 Then we're going to solve for x by subtracting x to both sides. We are left with, we would have 5 equals x minus 7. Then we're going to add 7 to both sides. 12 equals x. Therefore, we've solved for x. Now for example 2, it says line CD is the perpendicular bisector of both xy, line segment xy, and line segment st, and that cy equals 16. Find each length. So in part A, it's asking us to find CT, which should not be too difficult. Now, because CD is the perpendicular bisector for line segment XY and line segment ST, it means that this line segment, these two line segments are congruent, and these two line segments are congruent. Now notice the different tally marks that we're putting in, because the one on SM is not congruent to XD, which is why we differentiated by putting two different types of tally marks. Now if that's the case, we really have a couple different triangles that are congruent. We have the two smaller triangles that are here and here that are congruent, and the larger right triangles that are congruent. Now because we know that CS, line segment CS, is 12, then that must mean that line CT must also be 12. Therefore, for A, CT is equal to 12. For part B, it says find dy. Now, because we already know that XD, line segment XD is 7, and it's a perpendicular bisector, that means point D is equidistant from the sides. Therefore, dy equals 7. Now, it's your turn. Try these problems 1, 2, and 3. Post your answers to Edmodo. First person will reply, or first person will start it, everyone else will reply. That's all for now. See you guys next time.